Hello, my name's Miang, and for my project, I constructed a 4-bit adder using universal NAND gates in Minecraft. And for this project, my target audience are kids, specifically those who enjoy playing video games. Okay, so now if we go over here, we could see a row of various gates. These are AON gates and XOR gates, and they're all created using our universal NAND gate. And so first, let's just demonstrate how we're able to actually produce a NAND gate using redstone in Minecraft. And redstone is really similar to the electrical wires that we use in real life, and it's essentially transmitting power from one place to another. So these levers over here are acting as our power source, and they also represent the input bits for our Boolean circuits. So off would represent a 0, while on represents 1. Now, to demonstrate the truth value for our NAND gate and various other gates, these redstone torches were used. And basically, the way that they work is that when they're connected to a block with power, the torches turn off. So here, the block doesn't have any power, so it's on, but if I turn this on, the torch will turn on. I mean, off. Okay, so for NAND gates, return, it's going to output true when either or both of its inputs are false. So if I input 0, 0, as you can see, the light is on. However, if I input 1, 1, it turns off. And it's also on when we have 1 and 0. Now, since NAND is universal, we can now create our other gates, such as AND, OR, NOT, and XOR. So for AND gate, it's going to use 2 successive NAND gates, and it's going to output 1 when both of its inputs are 1. So as you can see, when I inputted 1, 1, that turns on. If I take 1 off, if I turn 1 off, the lamp over there turns off. And similarly for OR, it's going to return 1 when either input is 1. So as you can see, when I turn that one on, it turns the lamp out there on. However, if I turn them both off, we see that it turns off. Okay, and here is our NOT gate, and so this is just going to use one NAND gate, and it's going to require one input, and it's going to flip that input bit. So if I input a 1, it's going to output a 0. If I input a 0, it should output a 1. And finally, we have our XOR gate, and we're going to use this quite a bit in our 4-bit adder. Basically, it's going to use 4 NAND gates, and it's going to output a 1 over here when either bit is 1, and only when one bit is a 1. So if both inputs are 0, we know that it's going to output, if both inputs are 1, it's going to output a 0 over there. Similarly, if both inputs are 0, it also outputs 0. But only when one input is a 1 does it output true. So finally is our 4-bit adder, which we can see I constructed over here. And we can sort of get a bird's eye view if I try hard enough. This is the whole entire construction. Basically, each section is going to output 2 different outputs. So one output is a sum output, which is represented by these 2 lanterns. The sum output is represented by these 2 lanterns over here, and the second output is a carry out output. So that's going to be generated by this one one gate over here. So if I move down just so we can get a closer view, here are our input bits. So our inputs are going to be a 4-bit string, so bits string A and B, and these are the bits, as you can see, and we can control the values with the levers again. And in order to create the sum output, we are going to use a XOR gate in order to do so. So if we have 1 and 0 and we add that together, we should produce a 1. And for the carry output, that's going to be a little bit different. So we're going to basically construct the carry output by ANDing bit A with bit B. And so that means that if we have 1 and 1 as our input bit, we're basically going to generate a carry out into the second portion of our adder. And so for the following portions, it's going to be very similar, except that we're going to add an additional XOR gate. And this XOR gate essentially is just taking into account the carry in bit. So we're just trying to essentially calculate A XOR B XOR carry in. Now with the carry out, in order to generate that, it's going to be a little bit different from the first one. Basically, hopefully you can read this, but the carry out for these successive portions are going to be generated by doing this formula. So we're going to do bit A ANDed with bit B, all of that ORed with the carry in and a bit A XOR bit B. And again, this carry out bit is going to be the carry in to the next portion. And so we can quickly just demonstrate really quick how this 4-bit adder is being used. So for example, let's add 3 and 4. So for 3 and 4, let's say string A is 3 and string B is 4. So for string A, this should be on, that should be off, this should be on, which it is, that should be off, and then over here, this should be off and this should be on. I think I have that right, and it is. So as we can see, 3 plus 4, that should output 7, which we see here is 0, 1, 1, 1, which is correct.